is the first number 1/3 over 1 minus r, which is minus 1/3. And so this is 1/3 over 4/3, and I multiply above and below by 1/3 and I get 1/4. So we've got 2 points here, this g and this alpha, that are points in the Cantor set. And we'll see, are they going to say the weird thing? Oh dear, they've they've kind of missed the point of this question. So what happens here is that you keep taking away loads of lengths. So this is not an insert thing, this is a maths thing. You keep taking away loads of lengths, and you end up taking away a length of 1. And what that means is the length of the Cantor set is 0, but it actually does have points in it, which is weird. If you want to learn more about that, you have to do a pure maths degree. And it's very interesting stuff called measure theory. And the Cantor set is, you can go looking at the Cantor set on Wikipedia or whatever all day long. All day long. Okay, but that's that question done. A difficult question in my opinion. But we've just about managed to do it. Okay, question 8. Okay, question 8. The weekly revenue produced by a company manufacturing air conditioning units is seasonal. So what they're getting at there is they're selling more in the summer, less in the winter. The revenue in euro can be approximated by, there's a kind of a fairly complicated function here, where t is the number of weeks measured from the beginning of July, and the argument of costs is in radians. Find the approximate revenue produced 20 weeks after the beginning of July. Give your answer correct to the nearest euros. Okay, so this first part is easy. So there's basically just a function given, or revenue t, and it's asking for the approximate revenue produced 20 weeks after the beginning of July, and t is, okay, this is going to be fairly straightforward. You're just going to substitute in 20, and this is 22,500 cos pi over 26 by 20 plus 37,500. So it's just a calculator jobby, really. I'll write approximately. Okay, let's see what we get. Make sure I'm in radians, and 22,500 cos of pi over 26 by 20 plus, pretty important, 37,500. And I get the nearest euro 20,659. Piece of cake. Don't know what all the space is there for. Actually, the only thing I would remark about these leaving cert papers is the amount of space is no real indication of how easy or difficult the question is going to be. Like this one, it didn't need all that space at all. Question B, part B. Find 2 values of the time within the first 52 weeks when the revenue is approximately 26,250. Okay, so there's different approaches to this, but I think probably the easiest is just kind of solving the equation. Now I'm going to, well, I can divide everything by 1,000 in a second anyway. So I'm interested in the revenue being equal to 26,250. So I'm interested in R of t is, now I'm going to put in the R of t, but I'm going to divide both sides by 1,000 because it's just very messy otherwise. So I end up with 22.5 cos pi over 26t. There's a weird space on the exam paper for no reason there, plus 37.5 equal to 26.25. So I've divided already by 1,000. So it's just a little equation. I see 1, 2, 3, 4 things to get rid of. what we're going to have to be careful at eventually. Okay, so let's do the easy bits first. And we should, okay, so, and I'm going to, yeah. So take away 37.5 from both sides. And I get 22.5 cos pi over 26t equal to, let's use the L calculator, 26.25 minus 37.5. I get minus 11.25. Peel an equation like an onion, get rid of the multiplied by 22.5 by doing the inverse of multiplying by 22.5, which is dividing by 22.5. And so I get cos of pi over 26t equal to minus a half. The numbers, I'm sure, chosen carefully. Now here you get into trouble because they're asking for two solutions, and if you just do an inverse cos, you're not getting the full story exactly. Now what I recommend, you need to, okay, there's different ways. Okay, I recommend the best thing to do now is to look at the unit circle. So in the unit circle, the x coordinates are cos's and the y coordinates are sines. So you're looking, where is the x coordinate equal to minus a half? Here and here. These are the 2 points. There's different things you can do here. You can say, oh, what's the calculator going to give me for inverse cos of minus a half? That's probably fair enough. It'll give you one of these solutions. I'm fairly sure it'll give you the big one. You could do that. I think the way I would have thought was you look at inverse cos of a half. That would be, so that's, if that's minus a half, by symmetry that's a half, and you find that angle there, then we call it alpha. And then you have, that would be alpha, that would be alpha. So you get 180 degrees, which is pi minus alpha and pi plus alpha. I actually don't know how you do them these days, to be honest with you. I think I'll just show this old way of doing it. So the old way would say, okay, if you're trying to find an angle whose cos is minus a half, you draw this picture, these are the two angles. Well, that big one there and the even bigger one. So the pi, which is 180 minus alpha, and pi, which is 180 plus alpha. Where do you get the alpha? Alpha is an angle whose cos is a half. So this is almost like a little side work here. So cos alpha is equal to half, and this is where I would come in and hit the inverse cos. So you want to get rid of the cos, you do inverse cos. Hit it to both sides. See, there's issues about inverse cos. It only gives you the answers, I think, between 0 and 180. I should probably know that. I think it's 60 degrees. Of course, we'll want to be in radians. Pi over 3, yeah, 60 degrees, so that's pi over 3. And so this one is pi minus pi over 3. This is 2 pi over 3. And this is pi plus pi over 3. This is 4 pi over 3. So this thing is either 2 pi over 3 or 4 pi over 3. If you use the calculator, you'll just get this one. But the thing is specifically asking for two solutions. So I get pi over 26, t is equal to 2 pi over 3, or pi over 26, t is equal to 4 pi over 3. Here what am I going to do? I'm going to divide both sides by pi and multiply both sides by 26. So I'm going to multiply by 26 over pi, which is the same as dividing by pi and multiplying by 26. I end up with 26 is equal to 52 over 3. Does that go? Goes like 70. It's approximately 17.3. And this one will end up just being twice it. So this is or doing a similar story, you end up with t is equal to 104 over 3, which is approximately 34.7. What's the question? Find the two values of the time t within the first 52 weeks when the revenue is approximately this. Well, it's looking for just straight out values, so maybe I should be a bit more accurate and say that these are my two answers. Done. Does my answer make sense? So it's after July. 26,500 is, so this is 20 weeks after July. That's like 5 months. That's in December. That should be that's quite low. That's quite low. So 26,000. What am I doing here? Does my answer make sense? They're going to be symmetric actually. Okay, let's write something down here. Sorry. So what I'm mumbling about here is when you finish your paper and you look back, you say, have I answered the question that's asked, and does my answer make sense? Have I answered the question that's asked? Have I found the two values of the time t within the first 52 weeks when the revenue is approximately this? Yes, I have. Now I want to say, does it make sense? So t equals 0 is July. And does it say beginning of July? Beginning of July. So t equals 0, and it's weeks. So this is July. Now you have to be careful because 4 weeks isn't actually a month. So 17 weeks is about 4 months. So that's in November. And then this one will be like 34 weeks is something like 8 months. So it'll be another 4 months after this, which is March. So it's saying in November and in March the sales are kind of around this thing. Does that make sense? Well, we'll say no more about that. Okay. So it's saying find the derivative. Okay, so we need to differentiate this function here. It's not the hardest derivative in the world, but what you're looking out for is the chain rule. So I'm going to differentiate this from here. So r dash of t equal to, now of course I'm going to put back in the thousands and that. My recommendation is to fix the constant and then differentiate. So fix the constant there, 22,500. Now, if it's cos of t and you're differentiating with respect to t, the derivative is minus sine t and there's no more about it. But this is not cos of t, this is cos of the function of t, so you have to do the chain rule. The chain rule says you differentiate the outside. The outside function here is cos of t. The chain rule says you differentiate the outside function, so you get minus sine of t. Evaluate it at the inside, which is pi over 26 pi over 26t, and then you multiply by the derivative of what's inside. And to differentiate pi over 26t, I would fix the constant pi over 26 and multiply by the derivative of t, and the derivative of t respect to t is 1. So tidying that up, I would say this is equal to, now this divided by 26 might do something nice. Let's see, 22,500 divided by 26. Not particularly nice at all. Plus by minus is minus. I'm going to multiply the pi in as well, so it's going to be 1,250 pi over 13 sine of pi over 26t. That's the derivative, okay. And then the question asks us to use calculus to show that the revenue is increasing 30 weeks after the beginning of July. So remember that the derivative gives the slope of the tangent. And say if this is r and this is t, say look at the thing increasing and decreasing. When the function is increasing, the slope of the tangent is positive. So when a function is increasing, its derivative is positive. So to show that this function is increasing, all we'd have to do is substitute t equal to 30 into this and see that it's positive. So I'm just going to substitute t equal to 30 into this. Okay, so r dashed of 30 equal to. So now I actually only care about whether it's positive or negative. So actually this sign really doesn't matter. But the sign matters. This number doesn't really matter. But I'll throw it in. 250 pi over 13 sine of pi over 26 by 20. Now we can bang that into the calculator if we want. It is actually possible actually I'm looking at that, that's actually it's the wrong number because this is positive and so the whole thing would be negative. It's 30 weeks. So okay, look, we can all bang that into the calculator and get something negative, or positive, sorry. But I'll just show you a different way of doing that. If again you look at the unit circle, remembering the x's are the cosines, the y's are the sines. 30 over 26 is bigger than 1, but it's not that big. It's not as big as 3/4. Like 30 over 26 is 15 over 13. It's just a little bit bigger than 1. So this angle is like this. And what is the y coordinate there? It's negative. So the sine is negative. So this is negative by negative. This thing is definitely positive. So that's just another way of doing that rather than possibly going into the calculator, which is kind of the obvious thing to do. But anyway, what else have we got? Find the value for the time t within the first 52 weeks when the revenue is at a minimum. Use r double dash t to verify your answer. Okay, so this okay, so what we're going to get here, I think, there's different ways. Now it's saying use the second derivative. It's possible to do this question without any calculus as it happens. But, so here's a maximum, okay, and at a maximum, the first derivative, the slope of the tangent is 0. So at a minimum, it's also going to be 0. And this thing, we will find numerous solutions where this derivative is equal to 0. I think what we're going to do is we're going to try and just solve it equal to 0 and see what happens. And then we can go back and figure out, is it maybe it isn't a minimum. Okay. So a minimum, a maximum slash a minimum would be where this derivative is equal to 0. So we need to solve this equal to 0. So for a minimum, the derivative, this thing is equal to 0. Okay, so yeah, there's one very easy solution here, which is t equals 0. But the question is, will that give a maximum or a minimum? Now, looking ahead, so how would you solve this? Well, you have two numbers multiplied together giving you 0. So this isn't 0, so this sine term must be 0. And then just kind of naively just doing inverse sine to both sides. You get pi over 26 t is equal to 0, and then two numbers multiplied together giving you 0. You must have t equal to 0. Now what I'm going to do is I'm going to look at the second derivative, and we're going to see that this is actually a maximum, which is a little bit dodgy. A little bit dodgy, but we won't worry about that. Okay, so look at this thing here. There's different things to talk about, but for me, and this is something that's very important to wrap your head around. The slope here is positive, the slope here is 0, the slope here is negative. So if you're thinking just in terms of the slope, positive, 0, negative. So what we're going to show is that at t equals 0, that a second derivative is... Oh yeah, so here we were saying the derivative goes from plus to 0 to minus. And what that means is that the derivative is decreasing. Something that's going from plus to 0 to minus is decreasing. So that means the rate of change of the derivative is negative. And what's the rate of change of the derivative? Well, what's rate of change is derivative, so rate of change of derivative is derivative of derivative. So in this scenario, at a maximum, the second derivative is negative. Similarly, so at a maximum, the second derivative is negative. At a minimum, the second derivative is positive. So what we're going to do is we're going to look at the second derivative at t equals 0, and we're going to look at the sign, and let's see what we get. So if we look at the second derivative here, fix this constant, do another